Hey, welcome to The Explainer. So, you're getting serious about AI, right? Well, you've probably figured out that your ambition is only as good as your hardware. Today, we're going to break down exactly how to pick the perfect GPU to really power your work with large language models.
You've got the ideas, you've got the code, you've got the drive to build something truly amazing with AI. But pretty much every developer, every researcher, every hobbyist eventually smacks right into the same barrier. It's a massive computational wall. And the simple, hard truth is, your hardware just might not be ready for the job. And to put that computational wall into perspective, just look at this number. Models like GPT-3 are built with over 175 billion parameters. Think about that. Every single parameter is a value the model has learned. And trying to process all of them at once, well, it requires a staggering, almost unbelievable amount of power.
Okay, let's dive right in. Here's the game plan for today. We're going to start with that core power problem, then get into why GPUs are really the only answer. After that, we'll decode what all those technical specs on the box actually mean for you, look at the main players on the market, and finally, give you a solid framework for picking the perfect GPU for your needs.
All right, first up, let's really break down this challenge we're facing. I mean, it's easy to say large language models are big, but what does that actually mean for your computer when you try to get to work?
So here's what it all boils down to. Getting to the real power of these incredible AI models isn't just a software thing. Not at all. You could write the most beautiful, elegant code in the world, but if your machine can't handle the sheer load, all that potential just stays locked away. At its very core, this is a hardware problem.
So, let's pivot to the solution and look at how one very specific piece of hardware became the key to unlocking all of this potential.
And this comparison just illustrates it perfectly. See, a CPU, your computer's mean brain, is kind of like a master chef. It's brilliant at handling really complex tasks, one after the other, in sequence. But a GPU is like a whole army of line cooks. It has thousands of smaller cores all working at the same time, in parallel. Training an LLM means doing millions of pretty simple calculations over and over again, and that's the perfect job for that massive army of line cooks. Any GPU you look at has a whole laundry list of technical specs. So let's decode the ones that really truly matter when it comes to AI.
Okay, if you remember one thing, remember this. VRAM. This is probably the single most important spec. The easiest way to think about it is like the size of your workbench. Your entire AI model and all of its data have to fit on this bench to get processed. And if the model is too big for the bench, well, you can't even get started. It's really that simple. More VRAM lets you work with bigger, more powerful models. Period.
But, having a giant workbench isn't enough. You also need a super fast way to get all your materials onto it and off of it. That's where memory bandwidth comes in. High bandwidth makes sure your GPU isn't just sitting around waiting for data to arrive. It's the data superhighway, and it directly translates to faster training and faster processing. And now for the engines themselves. The CUDA cores, those are your general-purpose line cooks we talked about. But tensor cores? Tensor cores are the specialists. They are purpose-built pieces of hardware designed specifically to accelerate the exact type of math that AI uses. You can think of them like superchargers built just for your AI workload.
So, with those specs in mind, let's take a look at the two main arenas where these GPUs compete. You've got your consumer cards, and then you have the data center giants.
So on one side, you've got consumer cards like the RTX 4090. They're incredibly powerful, relatively easy to get, and awesome for gaming or, dipping your toes into AI. But on the other side, you have these data center behemoths like the H100. These are specialized machines with, astronomical price tags, built for one thing and one thing only, training AI at a massive industrial scale.
And nothing illustrates the difference more clearly than this chart. Just look at the VRAM, our AI workbench. A top-of-the-line consumer card gives you a very respectable 24 gigabytes. The data center card, a whopping 80 gigabytes. And that 80 GB number isn't random. It's a critical sweet spot that lets professionals load and fine-tune many of today's most powerful models all in one go. This, right here, is the great divide, and it really dictates the scale of the AI work you can physically do.
Okay, time to pull all this together. Let's build a really practical framework to help you make the right choice for your specific needs, not someone else's.
It really just comes down to these three simple but absolutely critical steps. If you work through them honestly, I promise you'll go from being totally confused to feeling clear and confident about your decision.
First things first, what are you actually going to be doing? Just running a model that someone else already built, that's called inference.
is the least demanding. Fine-tuning that model on your own unique data, that takes more power. And training a brand new model from the ground up, we're talking a massive, massive amount of VRAM and processing power.
Next up, and this is the big one, you have to be realistic about money. Your budget is going to be the single biggest factor guiding your choice. I mean, there's just no point dreaming about a data center GPU if you've got a consumer-level budget. You have to match your financial reality with your technical ambitions.
And finally, there's a step that so many people forget. A super powerful GPU is just a very expensive paperweight if it's not compatible with your software. So please, before you buy anything, double-check that the AI frameworks you plan to use, like PyTorch or TensorFlow, fully support that specific card and its drivers.
At the end of the day, choosing a GPU isn't really like buying a new hard drive. It's an investment in your own potential. The right piece of hardware literally removes barriers, opening up a whole universe of creative and developmental possibilities that were locked away before.
So, we've covered the problem, we've covered the solution, and we have a clear framework to help you decide. The key to unlocking all this computational power is now in your hands. So, the only question left is, what are you going to go create?